Okay, we're going to start on the second video of 5.2. This is solving quadratic equations. This is video number 2. And I think we'll get through the rest of the notes in this video. At least that is my goal. All right, see how it goes. All right, so let's just pick up where we left off. So this is a video following up on a page of notes. A couple of Ch5 problems that I had you work on. And I hope you can see this. Maybe I should zoom in just a little bit. Okay, that might be better. All right, so here are some Ch5s. I'll go ahead and show my process and explain each step, and then hopefully in the end your answer looks the same. All right, so I'm trying to isolate the squared thing. So the opposite of subtracting 2 is adding 2. Let me try to get my pen going here. All right, add 2. Add 2. So 1/3 of x squared is equal to 100. The opposite of 1/3 of something, right? So that's a fraction represents dividing, right? Dividing by 3. So we're going to multiply. Think of it as multiplying by the reciprocal or the opposite of dividing, but essentially we're going to triple both sides, right? And so this is now gone. So now I know that x squared equals 300. So I've isolated the squared thing, and the opposite or inverse operation of squaring is square rooting. So I'm going to square root both sides. So I have x equals plus or minus square root of 300. I'm gonna take 300. I'm gonna look at my my list of perfect squares, which is up higher on your notes. And you want to find the largest perfect square that is a factor of 300. Let's think about this. 100. 100 times 3. 100 is 10 times 10. So this is. In this step, you don't have to write as you get more comfortable, but I want to show you the thinking step formally. All right, this is a perfect square. This has an integer equivalent. Instead of a square root of 100, that is the same as 10. So there is my exact answer. And when I look at this on my calculator, scientific calculator is fine. I've got my graphing. 10. And the radical, there it is, 3. 10 times the radical 3 is 17.32, approximately. So x is approximately 17.32. Great. So those are my two answers. One is exact, and the wiggly is approximate. All right. So I hope you got that one right. Now this one is a bit different. Ooh, this is a good one. All right, so I'm going to go ahead and I don't have anything to add or subtract, but I do have this piece, right? I think the temptation is to try to, we're so used to distributing into parentheses. We're not. We're undoing these layers, right? Peeling things back until we can get x alone. So let's go ahead and isolate the squared thing, which is this binomial expression in parentheses. We're going to isolate that using inverses. So this is -4 times that thing. So I'm going to use the opposite of multiplying, which is divide both sides, keep it balanced. X, oops, darn, I wish I was using a pencil about now. X minus 5 squared equals negative divided by negative. Looks like, I think it's a 16. Yep, all right, so it's 16. All right, now I've got a squared thing by itself. So let's go ahead and square root as our inverse operation. So, oh, and you know what? I know what radical 16 is a 4. I'm just going to write that. X minus 5 equals plus or minus 4. Right, so x is almost by itself. I'm going to go ahead and finish this off with adding 5, adding 5. So I have x is equal to 5 plus 4. And I have x is equal to 5 minus 4. That's the plus or minus. All right, I'll go ahead and separate it out as two different order of ops sort of problems, different sums or differences, just because I want to really show you these are two separate problems, or two separate answers to the same problem. So 5 plus 4 I know is 9, and then the other option for x is 5 minus 4 is 1. Great, so these are my two answers. I don't need a decimal approximation here. Oh, that's kind of off the page. I don't need a decimal approximation here because these are integers, right? There's no radical left. I completely simplified this down to two integer values. All right, so let's go and take a look at, so hopefully you did well on that. That's just a little check-in to see if you've got some of the skills going into doing problems on your own on the homework. Let's go ahead and turn it over and take a look at the back. Actually, it's the back of yours, but mine, these are one-sided. All right, so we got another set. Now you'll notice at the top, it's that weird thing where once in a while, when I use the equation editor, only the character H is a box with a question mark. Oh well. All right, so that's an H. So let's read that. There's a triangle, ABC. If it's a right triangle and the right angle is at C, right? So just to remind you of naming. Right, so it's saying here is capital letters, A, B, C. If this is the orientation, then the right angle is at C. And what you may not remember, but we will talk about it right now, is that the side, in this case we're using lowercase, is opposite the angle on a triangle, right? So if this is angle C, then the hypotenuse, right, vocab for the long side of a right triangle is a lowercase c. And if this angle here between the bottom leg and the hypotenuse is B, that's the angle, then the side length is opposite, and that's a lowercase b. A little bit of notation just so you can decode the problems and understand what's being asked. All right, so let's go ahead and find the unknown lengths. We're going to use Pythagorean theorem here. A squared plus b squared equals c squared. All right, so the thing that I don't know is the hypotenuse, right? So this is going to take the place of my c. Right, so I'm just going to set this up sort of formulaically. It doesn't matter which one I use for my a and b because they're squared and then they're added. And added has that commutative property. A squared plus b squared is the same as b squared plus a squared. So those are arbitrary, but this must be c. Must be c. Sorry if you can't read that. I'm just going to say it. Must be the c spot. All right, so a squared plus b squared equals c squared. So that means, let's just go ahead and label this a and b. So I have 5.1 squared plus 2.5 squared equals, in this case, is z, something we don't know, squared. There's my setup. It's a substitution. Let's go ahead and simplify. I wonder if we're supposed to approximate here. I think we can do it without approximating. All right, so let's go ahead and use a calculator here. 5.1 squared plus 2.5 squared is 32.26. This is 32.26 equals z squared. And so now we have this squared thing by itself. So our solving step is the square root. I'm going to go ahead and square root both sides. So now I have, just go ahead and square root, oops, clear. Square, get out of here. Quit. All right, try that again. The square root of 32.26 is approximately 5.68, right? Because the thousandth digit is above 5, so we round the hundredths up to an 8. So that's 5.68. Okay, and they don't give us a unit or anything. That's kind of weak. All right, oh well. Interesting though, plus or minus, right? So we've always been doing plus or minus, but there is specifically, deliberately, definitely, absolutely not a plus or minus here. So let's see here. Let's write out why no plus or minus. Think about it. Think about it. If you have time to share, that would be great. Turn to your neighbor. What do you think? I'm serious. Hopefully you're talking to your neighbor right now. All right. So maybe you got there, but there is no negative length, right? These are actual side lengths, right? Lengths are not negative. That is an unreasonable answer, right? That's always nice to have that reflection piece at the end of a math problem where you ask yourself, is that reasonable? And this, is a perfect example of why, right? So is it reasonable? No, there is no negative side length. That makes no sense. And so this must be 5.68, whatever the units are. Okay, let's try another one. So in this case, let's just say this is A and this is B, and the C has to be here. The A and B could be switched. That's fine. So I have a 4.0 squared plus something, looks like they're using the letter P squared, equals the hypotenuse squared. Okay, so this is what I'm working with. It's a substitution problem for setup, and then we're going to go ahead and just subtract 4 squared is 16 from both sides. Use our opposite inverse operations to get the missing value by itself, square root. So 8.2 squared on 8.2 squared. And I was subtracting 16, right? Subtracting 4 squared from both sides, which is 16. So 16 gives me 51.24. All right, so P squared equals 51.24. So I know what the square is, so let's square root it. That's my inverse operation. And I get P is approximately, I didn't do that on the last one. Let's go add the approximately symbol there. Because I did have to round that. Right? This was not exact. There were a bunch of decimals there. I had to round it. So use your wigglies. Just for communication, right? Square root of 51.24 is 7.16, approximately. 7.16 units. Usually, kind of annoyed that the book doesn't have units, but these are examples, I think, right out of the book. We should practice labeling in units. Anyway, all right, so there we go. Couple problems. I'll go ahead and give you a chance to try these two on your own, just a couple minutes. Good time to pause the video and give it your best shot, and then you'll see the answers. Okay, good luck. Do your best. All right, so we're back. Here we go. Let's go ahead and say, this is my hypotenuse here. So this is my C. So let's say A squared, B squared equals C squared. So let's say 2.5 squared plus something I don't know. They're using the letter E, so I will use it as well. The other leg squared equals the hypotenuse squared. Let's go ahead and subtract. 2.5 squared is 6.25. I knew that. I shouldn't have used my calculator. It's just me being lazy. So I'm going to subtract 6 1/4 from each side. So 8.5 minus, clear. All right, 8.5 squared is 72.25. So that's this value here. And now I'm going to go ahead and subtract the 6.25 from both sides. So I have 66. So E squared equals 66. And I'll square root both sides. Square root of 66, not a perfect square, definitely, is 8.124. Okay, and in the directions it says to the nearest tenth, so we want to go 8.1. The 2 is below 5, so it rounds down. So we have 8.1. If I follow directions there, E is approximately equal to 8.1. There we go. All right, and now let's try another one. These ones we know A and B, and we don't know the hypotenuse. So we have 3.4 squared plus 8.7 squared, my 2 legs, equals the hypotenuse squared. Let's go ahead and add these together. Order of operations, right? Don't just add them and square them. We're going to square them, square the other piece, then add them. Exponents come before adding. But I'll use my calculator to help me with this. Why not? 87.25. Okay, so 87.25 is equal to t squared. Now I'm going to square root it, and I find that t is approximately. What am I doing? Square root of 87.25. 9.34. Oh, but they want tenths, so just about 9.3. There we go. So hopefully you did well on those, got them right. You'll see very similar problems in the homework. I tried to create these notes based on similar, not exactly, but very similar problems you'll see in the homework. So hopefully they'll prepare you. Just a reminder, these are posted on YouTube, linked to my channel on my website under the Algebra 2 page. So if you need to grab a hold and take another look at these, or a friend missed class, refer them to this, and they'll get a chance to get the notes. All right, so let's go ahead and move down to the last one. Okay, so with any sort of word problem, multiple pieces, I always read it a couple of times. So here's a tower with support wires. How far apart are the support wires where they contact the ground? All right, so let's just, let's decode this into like a very specific question. What is this really asking us to find out? So how far apart are the wires? So here are two wires. Where they contact the ground. So I guess this is really asking me, right? So if I rephrase, let's do this. Here's the question. What is the length of the segment BA? That's really what's asking, right? What is this? All right, so that's pretty straightforward. I think we know the height, we know some hypotenuse values or lengths. So what we want to know is the value of this. Okay, so let me just call that one, doesn't matter. Let's call this one, let's find out what CB is. I'll use the geometry notation. Let's find out what CB is. Okay, so we want to know CB. And then I want to know what CA is. It's bigger. Right? If I know these two values, well, I can subtract this from this. So I'll take this long length and then subtract out this shorter CB length, and what'll be left is this missing value, right? So it's two Pythagorean theorem problems and then subtraction. All right, so let's start with here myself. I'll say let's do this first and this second. All right, so I'm gonna first find this DCB. So a squared plus b squared equals c squared. So the leg here we know is 760 feet. So we're going to square that. And then we're going to add it to, let's just call it segment BC. We don't know what that is, squared. And it will give us the hypotenuse squared. So the hypotenuse, careful with the arrows, is this one. All right, so that is this first triangle on this smaller, narrower triangle in here. All right, so so the length that I'm dealing with here, use my calculator. 850 squared minus 760 squared. Move this over. Here, 850 squared minus 750 squared. This is not the same thing as 100 squared. It is 160,000. So BC squared segment equals 160,000. So I have a thing squared, so I'm going to square root both sides. So this leg length BC is 400. I'll confirm it. Square root of 160,000 is 400. All right, so that's the short length here. Let's see what the long one is. So the A is the same, right? It has the same height here, so that's still my A value, so it's 760 squared. And now what I'm looking for is the longer length. So that's CA. So that's my bottom leg here. That's the missing piece, right? The distance, this larger piece. Just to recap, right? We're finding the large distance, and we're finding the smaller distance, and then we're subtracting the smaller from the larger because this piece, this length is what we don't know. All right, so and that will equal, my hypotenuse of the larger triangle is 900 squared. So I'm going to go ahead and subtract 760 squared, 760 squared. So I know that the length CA squared is, calculator help, 900 squared minus 760 squared. Well, that's interesting. 232,400. 232,400. Let me just double check my math here because that's a weird number. That looks right. I'm going to go with it. Same height, different hypotenuse, subtracted. Seems reasonable. Typed it in correctly. All right, I'm going to go with it. So now I'm going to square root both sides. And the square root of 232,400. Maybe that's perfect square and I didn't know it. It is not. All right. 482.08, let's say, approximately. All right, so there's my longer length, there's my shorter length. So my actual answer here, I'm just going to come down here at the bottom. So that means the length AB is 482.08 minus 400. So that is, well, let's use approximately because there is an approximation decimal in there. All right, so I'm going to say approximately 82.08. And this one does have units of measure. So let's say feet, and it's just feet. It's not squared because this is a length. Squared would be an area. So there is my answer. Awesome. So yeah, I feel pretty good about that. If I had a book handy, I did not bring one with me. I would double check that that was right. I mean, that's really the last step. And the only reason I'm a little bit skeptical is because this turned out to be a nice, perfect square here. That was square rooted into an integer. And this one had a decimal, but I honestly feel pretty good. I've already double checked my work. It's a reasonable answer, so I'm going with it. All right, good luck with the homework. I hope it goes really well. If there's any issues, feel free to comment in the video section on YouTube or send me an email. I'm tied up during the day, but I definitely get caught up on all my emails in the evening. So I hope things are going well, and look forward to seeing you next week. Keep it up.